Hello, welcome to another Midnight Maths video. In this one, we're going to practice setting up a definite integral with an AP style for your response question. I encourage you guys to pause the video, read this question, and try to attempt it yourself. And then once you're done with that, you can watch this video and see how you did. So here we've got cable that sells for $120 per meter. Now, this sentence is pretty straightforward, right? What that means is if you've got a cable that's X meters long, right? Then you're going to make 120X in revenue, right? And one way you can check whether this expression is correct is by checking the units. So we know that it sells for $120 per meter, and so that will be dollars per meter, and you want your units to be dollars. And is that the case? Well, X is in meters, and so you can do your unit check, and yes, indeed, 120X will be in dollars. And so you know that for X meters of cable, you can make 120X. Okay, great. Now, what about for a cable of fixed length, the cost of producing a portion varies with distance. And so this sentence, these two sentences right here, are probably the most important of the entire problem that I've shown here, because that's really how, if you misunderstand these sentences, you're going to get the whole problem wrong. So one thing to note here is you should really be using your units to help you interpret the problem. And here they give you clear units. AP style problems will always give you clear units for every quantity, and you should pay attention to those. So here we've got 6 root x dollars per meter. And so this is not a dollar value, right? Not a dollar value. And so you cannot use that as a dollar value. We're going to investigate what these sentences mean when we solve part A. So let's get to it. So we're going to find this very long 25 meters, right? That's very long for a cable. I mean, maybe not long for a cable, but it's a long length. Now, the thing here is when you read this problem, you should really keep an eye on this portion here. So the cost to produce a portion, a small portion of the cable that's X meters from the beginning. So let's draw that. Maybe we'll say this is some X meters. And the cost to produce a portion, maybe this portion of the cable, is 6 root x dollars per meter. Now, that's a little bit of a mouthful, but even if you don't mathematically know how to attack this yet, one thing that should be clear is that the wire is going to cost different amounts to make depending on where you are on the wire. And if it's 6 root x dollars per meter, you know that this function increases as a function of x from 0 to 25. And so you know that this portion will be less expensive than that one. And then that portion toward the end will be even more expensive, right? And so these are some good things to keep in mind before we mathematically formulate the answer to this problem. So let's look at profit. So the College Board gives the definition of profit as revenue minus the cost. But now the trick is we can't just do this with a simple multiplication, because the cost to make this portion is different to make this portion, and so on and so forth. And so this is on a calculus test, and so we're going to be using calculus to figure out the profit. So to figure this out, we know that each portion has a different cost, and so let's just consider one portion at a time. So let's take a very, very small portion of the cable, a dx, small dx. So we're moving a small dx meters along the cable. And we're going to say that this is our x distance from the beginning of the cable. If we can figure out what the cost to make this small dx of that cable is, then we can add up all the dx's along x equals 0, go all the way to x equals 25. We can do that with the definite integral, and then we'll get our answer. And so what's the revenue that we get from this dx portion of the cable? Well, we know that it manufactures, it sells for 120 per meter. And so if dx is in meters, we're going to make 120 dx. Because, like we said earlier, we've got x meters of cable. We're going to make 120x revenue of that. And so even if we take this x meters, now we shrink it to a very small dx, then we're going to make 120 dx meters. And we can check our units, right? I've emphasized the importance of units throughout this problem. So $120 per meter, and dx is in meters, and so we end up getting dollars. That's good. Now we're going to subtract the cost. Now the cost is going to vary depending on x, where we are from the beginning. And so this expression for cost should have an x in it. And indeed it does, because we're going to be using this 6 root x right here. Well, in the revenue case, it was a constant $120 per meter. In the cost, it's going to be 6 root x dollars per meter times our dx, how long this small piece is. This is, again, similar to the above case, except now our rate is just changing. So now if we've got a dx cable, we're making 6 root x dx dollars. But this only applies to a very small dx, because that's the extent to which this function applies, right? You can't use this for a larger portion of the cable. You'll have to integrate to do that, and we'll do that in a second. Now we've got this as a sort of skeleton, but now we need to finish the integration, so we're going to write this s symbol here, and we're going to go from x equals 0 to x equals 25 meters, right? And that will be our profit for a 25 meter cable. And so luckily there is a calculator to do this one. It isn't that bad to do by hand, but we've got a graphing calculator here, so we can use it. And once we plug it in, we'll end up getting $2,500 for the profit. And so one thing you want to check is you should always do a sanity check of your answers. Does this make sense? Well, let's forget the cost for a moment, and let's just find out how much revenue we make. The revenue is a pretty straightforward calculation. It's $120 per meter times 25 meters, right? And we'll end up getting $3,000 for that. And yes, that does make sense. We're making $3,000, but we had to pay some $500 to make the cable, and so yeah, we're in the right ballpark. So now let's look at part C, where now instead of 25 meters, we're looking at K meters. So if we wanted to generalize this as a function of K, we're going to be using pretty much this expression. So I'm just going to copy this here, right? But for 25 meters, we had this 25 at the top. If we had a 30 meter cable, maybe this is 30 meters, then what's going to change in this expression? That's right, the top is going to change. The top is going to change to 30. And if you had a 50 meter cable, your top would change to 50, and so on. And so if you want to find a K meter cable, you have to put a K on the top, right? And so this would be your generalized expression now, generalized equation for the profit of cable of length K. And you can, of course, simplify this a little bit, do some integration here, where you get 120K and then subtract this definite integral. And here you can really, with this one, you can also see that this part is pretty constant, right? The 120 was a constant revenue, and so you can just do a multiplication here. It's no big deal. But then over on this term, when we figure out the cost of making the cable, it changes depending on the portion, so we have to integrate. Alright, that'll be it for this video. I'll see you guys in the next one.